Okay, so what we're doing today is mixed factorisation 7.6. There's no examples in the book because the examples are in the previous parts of the book, but you are going to be doing exercise 7.6 and all the odd numbered questions. So what I'm going to do here, and I'll give you an option as to whether you want to watch it, but what I'm going to do here is I'm going to do all the even numbered questions as examples. So what you can do is, if you're really confident and you want to save time, you can go straight to the book and start working through the questions. Otherwise, you can watch the video, you can watch it all the way through, you can fast forward, you can just pick the questions you want to see. It's up to you how you use this video. Okay, now we're starting with this one. This one is a hard one. This is probably one of the harder ones we're going to do. And sometimes it's hard to see the entry point. And I was a little bit confused here because I was looking at things. I could see that there was an X and an X. And I could see that there was a whole lot of square numbers with 4s and 9s. But then when I looked more closely, I found out that this is a square. That is X plus 2 squared. Okay, so 2 there, plus 2x plus 2x. So x plus 2 squared is x squared plus 4x plus 4. Okay, then we're going to minus. I'm going to make the 9 into a 3. I'm going to make that 3y all squared. And we have a difference of 2 squared. So to solve this, it's going to be x plus 2 minus 3y times x plus 2 plus 3y. Difference of 2 squares. So all we're going to do is x plus 2 minus 3y times x plus 2 plus 3y. And that's the first one done. Okay, now I'm going to move through these reasonably quickly. You can pause, you can come back, you can replay them. If you want to copy any down, you can just pause and copy them down. It's up to you how you work. So I'm going to work through these. There's 17 more questions to do. I'm going to do it reasonably quickly. Okay, if you've got any questions about any of them, just ask me in Teams chat. Okay, this one, x squared minus 49. That's a squared, obviously. So 49 is a squared number. You need to be able to recognise your square numbers. So we've got x squared minus 7 squared, which is x minus 7, x plus 7. And just for those who are curious, it doesn't matter which order you put these because it's just two numbers multiplied together. So you could do the x plus 7, x minus 7 if you wanted to. Question 6. Just two terms, x in one, y in the other. The only thing that's common is 5. So we're going to make this 5 times 3x minus 5 times 4y. The 5 is common, and we end up with 3x minus 4y in the bracket. 5x squared minus 80. Okay. What we want to recognise here is that 5 is common. Okay. So we're going to take the 5 out, so we're going to make it 5 outside the brackets, x squared minus, and it's 5 times 16 to get to 80, so x squared minus 16. Now what I notice though, so we've already factorised, that's factorised, but we've still got an x squared in there. Usually when we factorise, we want to get rid of the x squared, but that's a square number. So it's the same as, and this step's optional, x squared minus 4 squared, but I'm just putting the step in so you can see what we're doing. Difference of 2 squared, so it's x minus 4x plus 4. So we end up with 5 bracket x minus 4 x plus 4. Okay, question 10. Quadratic trinomial, an x squared term, an x term and a number, flag and cross, x squared, the only factors are x times x, and then we need two factors of negative 12, two factors of negative 12, and we want it to get to be 1, so I'm going to go plus 4, so I'm going 4 and 3, make the 4 positive, the 3 negative. That's 4x minus 3x gives us 1x. Okay, so now we're just going to factorise, and we go across x plus 4 and across here x minus 3. Question 12. X squared minus 7. Doesn't look like there's much you can do here. There's not much to play with. So we've got to just be clever. Okay, so here I'm going to manipulate just so we can do something. I'm going to make 7 square root of 7 squared. Square root of 7 squared equals 7. So we haven't changed anything. Now we've got a difference of 2 squared. So this is going to equal x minus the square root of 7 times x plus the square root of 7. Okay, so that's all we could do there. Okay, 5x squared plus 60x plus 100. Let's look at two different ways. So we could just go straight to flag and cross. Factors of 5x, we're going to have to go, I think it's going to be 5x and x. Probably not going to get this in the first go, but that's fine. We'll just give it a shot though. So factors of 100. 100 is 10 times 10. Could start in the middle. Actually, I've always said to start in the middle, so we better do it. 10 times 10. They're going to be positives because we need a positive answer. Okay, so here that's 50x, and that's 10x. 50x plus 10x is 60x. That's fine. So we've factorised it one step. That's good. 5x plus 10 is the first bracket, and the second bracket is x plus 10. But 5 and 10, 5 goes into both of these terms, so we can bring a 5 outside this bracket. So we can take the 5 outside that bracket, and we're left with just x on this side, and 5 times 2 is 10. Okay, and that's factorised. Now, the other way, what we could have recognised here is we could have recognised straight away that 5 is common. Sorry about the mess in the middle. So we could recognise 5 is common. So I could have straight away just taken 5 out. We've got x squared, 5 times 12 is 60, so 12x, and 5 times 20 is 100. And then we just do flag and cross on this simpler one. Okay, now we need two factors of 20. They're going to add to 12. So we're going to go 2 times 10. Both positives. So we've got we've got 10x plus 2x is 12x, which is what we want. So now that's going to equal, the 5 is still there. We've got an x plus 2, and we've got down here an x plus 10. Both the same answer, two different ways to get there. Okay, question 16. Question 16. We have, once again, one of these messy ones, but once again, the 8 and the 16 here just sort of signal to me there's a link there, okay? And if we have a look at that, and if you probably should have all those squared functions in your bound reference and just go and look at them if you think. So this is actually going to be x minus 4 all squared, because 16 is 4 squared, and minus 8 is minus 4x and minus another 4x. Then we go minus y squared. Now we've got a difference of 2 squares. So we've got x minus 4 minus y times x minus 4 plus y, difference of 2 squares. It's factorised. Okay. Question 18. You're going to notice that there's two terms with f in. I'm just going to change things around a bit. So I'm just going to rearrange it. F, G plus, I'm going to bring the f terms together. 2G plus 2H. So we've got f's G and H, 2's G and H. So here we're going to just factorise, take the f out and we're left with G plus H. Take the 2 out and we're left with G plus H. Now we've got a second stage of factorising because G plus H is common. So we're going to take the G plus H out, and in this term we're just left with f, and this term we're just left with 2. Okay. Question 20. First thing, 5 is common everywhere. 5s and 10s. So 5 is the only thing that's common everywhere. So I'm going to take the 5 outside the brackets and just simplify it a bit. So that's 2mn minus n plus 2m. Oh, higher up. Taking the 5 out. 5 is 5 times 1. So we just left the 1 on the end. Okay. And we take the 5 away. 5 times 1. So we need to put the 1 down. Make sure you do have that one there. Okay, now what I'm going to do is I'm going to put the m terms together. So 5 bracket 2mn plus 2m minus n minus 1. Now, it's sort of just evolving, okay? We're just seeing bits of it. It's a little bit confused by these minuses, okay? So what we're going to do is we're going to take the 2m out of this one. So equals 5, I'm going to go 2m bracket, we just left n plus 1 there. And what I'm going to do is I'm going to take minus 1 outside here, and that leaves me with n plus 1. Okay, so how does that work? So what I've done is I've taken the minus 1 out, so when we expand this, minus 1 times n is minus n, minus 1 times 1 is minus 1, and it's given us an n plus 1 in each of them. So now I'm going to go 5 bracket, and I'm going to take the n plus 1 out as common. And here we're just left with 2m minus 1. Okay, and we don't really need that other bracket. Okay, just tidying it up a bit here. Put the 5 outside. So we're taking the n plus 1 out as common. We're left with 2m on this side. We're left with minus 1. That is factorised. That is a tough one to see. You just got to try and work through it. If you can't quite see it, sometimes these you can't see all the way through. Okay, you just got to work through with what you do know. This is a nice easy one. A quadratic trinomial. flag and cross, x times x is x squared. 11 only has two factors, has to be 11 and 1. Okay, 11's a prime number. We've got negative 11. Okay, so one of these has to be negative, one has to be positive. We want to get a negative 10, so we're going to make that minus 11 and plus 1. Minus 11x plus 1x is minus 10x. So we're happy with that. So we group these together and we get x minus 11 bracket x plus 1. It's turned into a marathon. Question 24. Okay. We have some minus 5s and we have some c's. So let's group them together. Minus 5a minus 5b. The sign in front always goes with the term, plus AC plus BC, and I'll just put it so it goes AB, AB. So this part, the first part, we're just going to take minus 5 out as a common factor, and that leaves us A plus B. Be careful with this one. We've taken the minus 5 out, so when we take the minus 5 away, we're left with plus B. And here we're going to take C out, and we're left with A plus B. A plus B in the bracket, A plus B in the bracket. We do a second level of factorising. So we take the A plus B out the front, and we're left with minus 5 plus C. Okay, that answer is fine, but a lot of people would prefer to put the switch these around. So write or because both answers are correct and both answers are quite final. So we could write that as C minus 5 just so we've got a negative sign at the front. Okay, on to question 26. Question 26, with no numbers in common. That's a quadratic trinomial, so we're going to go straight to flag and cross. 3 is a prime number, so the factors have to be 3x and x. And factors of 2 have to be 2 and 1. Now the thing is, we need to get a 5. So I'm going to put the 2 down here so it goes with the 3x. 2 and 1. And then I've got 2, that's going to be 6x plus 1x. That's going to give us 7x. So, I thought I was going to take the shortcut, but that one's not going to work. So we just cross it out, and we start again. So now we're going to go 2 and 1. Okay, so this one is going to work because this is 3x. 1 times 3x is 3x, and this is 2x, so that gives us 5x. So sometimes, as I said, we don't get these all the time. Everything's positive because it's all positives in there. So this is going to equal 3x plus 2 times x plus 1. Question 28. Once again, a quadratic trinomial, all multiples of 4. Every one of these numbers is a multiple of 4. So what we're going to do is we're going to take 4 out as common, but they're all negatives, so I'm going to take out negative 4 out as common. What that does is turns everything to positive. 4 times 7 is 28, so we get 7x. 4 times 6 is 24. Okay, because I've taken a negative outside the bracket, everything inside now is positive. So we're just going to do flag and cross on these. So 6. We could go 3 and 2, but 3 and 2 isn't going to get us a 7, so we're going to have to go 6 times 1. So we've got 6x plus 1x is 7x. Happy with that. So this is going to equal minus 4, has to be still there. These are both positive, so we go x plus 6 and x plus 1. Okay. Question 30. 3x squared minus 27. Okay, this is masked a little bit. You can't actually see what to do because we're actually going to do a difference of two squares, but you can't see the squares because 27 is not a squared number. So what we're going to do, 3 goes into both of these, so we're going to take the 3 out first. And then we're left with x squared minus 3 times 9 is 27. X squared minus 9, 9 is a squared number. So now we've got a difference of two squares. X squared minus 3 squared. So inside the bracket, this is going to be x minus 3 times x plus 3. So we go 3 bracket x minus 3 bracket x plus 3, and that's our factorised answer. Getting close here. X squared minus 11, this is just the same as the one we had before with the 7. We're going to do a manipulation. So we're going to make that the square root of 11 squared, a difference of two squares, and we get bracket x minus the square root of 11, bracket x plus the square root of 11. Okay, x minus 1 squared minus 4, that's a square, 4 is a square number, so we're going to make this x minus 1 squared minus 2 squared. So, difference of two squares, x minus 1 minus 2, x minus 1 plus 2. So we go x minus 1 minus 2, bracket, then we've got to go the x minus okay, so multiplied by x minus 1 plus 2. Okay, so factorise two numbers multiplied together. And I believe this is the last one. Okay, that's a square. 25 is a square number, so we're going to go 2x plus 3 squared minus 5 squared. So this minus this, then this plus this. So we're factorising 2x plus 3 minus 5, then 2x plus 3 plus 5. These numbers, we can add them. 2x minus 2 and 2x plus 8. Oh, we still keep going. So we've got 2's in here we can take outside. So 2 bracket x minus 1. When we take the 2 out, we get left with 1. Times 2 bracket x plus 4. And 2 times 2 is 4. This is just the one that keeps going and going and going. Not hard, but sometimes these happen and there's more you can do. If there's more you can do, you need to do it. So it's fully factorised there. That's factorised. Nothing wrong with that. It's factorised. That would work. That is fully factorised and simplified. Okay, so there we go. 18 questions. Not as quick as I wanted to go. A few interruptions along the way, but we're there. Just use these how you want to use them. All the best. Ask me questions in Teams chat if you need help.